Section 8.5 Comparison Test. This section will look at the direct comparison test and the limit comparison test for the positive series. The direct comparison test, or is called the basic comparison test. Let the series AK and BK be series with positive terms. We're going to compare with the series BK. If we know that BK converges and AK less than or equal to BK, then the series AK converges. For the comparison series BK, which we know that it diverges, and the BK less than or equal to AK term, then the series AK diverges. The second comparison test, which is called the limit comparison test, let the series AK and BK be series with positive terms. Let the limit of the ratio, the AK over BK, as K approaches infinity equals L. Case 1, for the L as a finite positive number, then the series AK and series BK both converge or both diverge. For the case that the L or the limit value is 0, and the series BK or the comparison series converges, then the series AK converges. The last case, the limit value is infinity or doesn't exist, and the series BK or the comparison series BK diverges, then the series AK diverges. The key of using the comparison test is to find appropriate comparison test. And in our problems, we're going to use the P series as a comparison series. For the P or the power of the K greater than 1, the P series converges. For P or the power less than or equal to 1, the P series diverges. Example, use the direct or the limit comparison test to determine whether the following series converge. In part A, we have the AK as 1 over 10 k squared plus 2. Consider the term as k approaches infinity. AK approaches the value 1 over 10k squared, as 10k squared is the leading term of the denominator. Now we are going to use the comparison series, which is the P series, as the BK term in the form of 1 over 10k squared, which is 1 over 10 times 1 over k squared. Then the series that we are using to compare is the series 1 over 10 times 1 over k squared, or the P series with P equals 2, and the number 2 is greater than 1. We know that this series converges. For the direct comparison test, to compare with the convergence series, the BK term on the right hand side greater than or equal to the AK term on the left hand side for k greater than or equal to 2. As BK 1 over 10k squared and AK is 1 over 10k squared plus 2. This inequality is true for k greater than or equal to 2. Since the right hand side is a term of the convergent series, therefore the left hand side, which is the AK term of the series, will converge by the direct comparison test. And we can also use the limit comparison test for this series, which is more convenient. So the limit of the ratio AK and BK as k approaches infinity in the form of the limit of 1 over 10k squared plus 2 multiplied by the reciprocal of the BK, which is 10k squared over 1. K approaches infinity, and the limit value is 1, which is less than infinity, or the L, or the value L here is the finite real number, which is a number less than infinity. So by the limit comparison test, this series AK also converges. For this example, the AK is 1 over 4 square root k plus the cube root of k. Consider the term as k approaches infinity. The, lead, the leading term of the denominator is the one with the higher power. Since square root k is k to the 1/2, the cube root of the k is k to the 1/3. So k to the 1/2 is the leading term. So we can say AK approaches to the term 1 over 4 times k to the power 1/2 and use the comparison series or the P series as the summation of 1 over 4 times k to the 1/2, which P equals 1/2 less than or equal to 1. So this series or this comparison series diverges. For the BK equals 1 over 4 k to the 1/2. It's more convenient to use the limit comparison test because we do not have to worry about the true statement of the inequality of the AK and the BK. But if we want to use the direct comparison test, we can do that as well. To compare with the divergent series, the divergent series term will be on the left, less than or equal to the AK term on the right hand side. We are going to set up the inequality list as the AK or 1 over 4 square root k plus the cube root of the k must be greater than or equal to the BK term. Let's say which if we use the one that we found as the leading term or the 1 over 4 times square root k, is that true? So this is the sensitive part of the use of the direct comparison test. On the note here, as the term, we know that 4, so 4 square root k is less than or equal to 4 square root k plus additional term. But we can add one more term on the left hand side to have the coefficient 5 of the square root k to make the 5 square root k greater than or equal to 4 square root k plus the cube root of the k. So then the reciprocal, so this one, the first setup is not true. So we're going to rewrite it as 1 over 5 square root k less than or equal to 1 over 4 square root k plus the cube root of the k for k greater than or equal to 1. And since this is the BK term of the divergent series, so by the direct comparison test, the series AK diverges. It's more convenient to use the limit comparison test since we get the leading term of the AK as k approaches infinity to be 1 over 4 times k to the power 1/2. So we use BK as 1 over 4 times the square root of the k. And then by the limit comparison test, the limit or the value L, which is the limit value as k approaches infinity of the AK divided by BK in the form of the limit of 1 over 4 square root k plus the cube root of the k multiplied by the reciprocal of the bk or 4 square root k. For k approaches infinity, the value equals 1, which is less than infinity. We have the same conclusion that both series AK and BK diverge.